And now we get to work with related rates. Rate, that means derivative. S at the end means it's plural. So we're basically working with equations that have more than one rate or more than one derivative. For this first example, this object is traveling around in a circle. It could be that there's a rock in somebody's tire, and as they drive down the road, the rock's going around and around. I envision that it's going this way. Okay, so this is a circle with a radius of 3, so I could use the equation x squared plus y squared equals the radius squared, so it equals 9. Sometimes in these problems you're given the equation, sometimes you need to create it yourself. Then to the question. So then find dx dt if dy dt equals 2 feet per second when the x is equal to 2. So what does all that mean? Well, first of all, we'll start with the easiest part. X equals 2 means we're talking about that x equals 2 right there. We're also going to need to find out what y is. So we could use this equation, plug in a 2. That would be 2 squared plus y squared equals 9. Subtract 4 from both sides. Y squared equals 5. And usually when you take the square root, you're supposed to put plus or minus. But right here, that y value is positive. So it's going to be y equals the square root of 5. At this time, there's no real reason to get a decimal for that. I'm just going to leave it as accurate as possible, the square root of 5. Now, what does all this stuff mean? So these are the two rates that are being talked about. Related just means there's an equation. Then rates is the two derivatives. So what happens is, as this object moves from one point to the next point, it's going to have to move to the left, and it's also going to have to move up. Of course, it doesn't go like a triangle straight over to the left and straight over up, straight up. But as it moves from here to here, it's definitely moving to the left and it's definitely moving up. Now this part is talking about the y value. So this is talking about going up or down. Because this is a positive, it's going up. Now find dx dt. So this talks about, is it moving to the left or to the right? So with this equation right here, we're going to take the derivative using implicit differentiation. Notice that this is saying the independent variable is t, and yet you see no t in here. So when we go to take the derivative, take the derivative of x squared. So that would be 2x is to the 1 power. And now do the chain rule. Take the derivative of x with respect to t. Then for the y squared, take the derivative. So it's going to be 2y. And then do the chain rule. Take the derivative of y with respect to t. And on the right side, the derivative of 9 is 0. Then we need to solve for dx dt. We also have numbers that we can plug in, and the order on that doesn't matter. You can plug in the numbers and then do the algebra, or you could do the algebra and then plug in the numbers. I think I'll plug in the numbers. So x equals a 2. dx dt is what we need to solve for. Y, we found out, is the square root of 5. And it's given that the dy dt is equal to 2. All right, then just solve for dx dt. So subtract this from both sides. So that's going to be negative 4 times the square root of 5 on the right side. And this will be 4 dx dt. And then just divide both sides by 4, and actually the 4's are going to get canceled. So dx dt is equal to negative the square root of 5, or now I'll get a decimal here at the very end. The square root of 5, 2.236. Negative 2.236. And the units would be in feet per second. So this is basically saying when x equals 2 and it's at that point right there, then it's going up at 2 feet per second. And then negative on this part right here means it's going to the left. So it's going to the left by 2.236 feet per second. All right, let's try another one. So with these, they've got quite a few words, so I went ahead and wrote them out first. So there's these two runners. They start from the same place, and I guess they don't really like each other because they started running in different directions. One person goes north, 8 miles an hour. The other one goes west, 10 miles an hour. So one person is going to run north. So let's say that they're starting from this point right here. There's the parking lot. And then one person starts running north, and the other one goes west. Person going west is a little bit faster, so for their distance, I'll make it a little bit bigger. Okay, now when you make these pictures, if there's something that's going to change, then you can't put a number on it, you need to put a variable. So over here, this represents the distance that this person has run. So I can't just put like a 12 that they ran 12 miles, a 10 like they were going 10 miles an hour. I have to use a variable. I'll use x. And likewise, this person is going to be y. And then for the distance between them, that's going to be this red distance right here. And then I'm going to call it S. So the letter S is used for distance quite often. Let me just grab an extra piece of paper. It seems like a good idea to use D for distance, but then we're going to take the derivative of it. And then DD just sort of looks weird. Like, did the person really mean to write DD? So we'll use S. So with this one, we need to come up with our own equation. Well, since the north and the west are perpendicular to each other, we've got a right triangle. That means we could use the Pythagorean theorem. X squared plus y squared equals S squared. Okay. How fast is the distance between them increasing? So this right here is saying find the derivative of s with respect to time. And then this would be in miles, the s, the change in the distance, and this would be time, so this would be in miles per hour. So that's how fast the distance between them is changing. All right, just like on the last one, take the derivatives. So we would have 2x times dx dt plus 2y times dy dt. And then on the other side, it's going to be 2 times s times ds dt. Now we need to solve for this one, ds dt. And we need to plug in the numbers. Well, what are the numbers? Well, if they've been running for 2 hours and this person is running 8 miles every hour, then that means that for this person, after 2 hours, they've run 16 miles. And this person has run 20 miles. So this is the person running 10 miles an hour. So when t equals 2, that means that x has run 20 miles and y has run 12 miles. So we now have a number for x and a number for y. And since we already have the 12 and the 20, we could actually plug those in and we could solve for s. So on these problems, quite often you'll have the calculus part, and then over to the side you'll have some algebra part. So keep those separated. So over here is going to be the algebra part. So now using the Pythagorean theorem, 20 squared plus 12 squared equals s squared. So then take the square root of that. So then, what is the square root of 20 squared plus 12 squared? It's a 23.324. So s is equal to 23.324, and that's miles between them. Okay, so now we start substituting the information in. So we would have 2 times x, which is 20, and then dx dt means how fast is that person running. So that person is running 10 miles an hour. Plus 2 times y, so 2 times 12. And then for the y person, how fast are they running? 8 miles an hour. And then on the right side, it's going to be 2 times what we just got for s, 23.324, and then times the ds dt. So now all we need to do is add up all of this and then divide both sides by that. So this is going to be 40 with an extra 0 at the end. That's 400. 8 times 24. How about 24 times 8? How about trying to not use the calculator, but that's okay. 192. Yeah, that's what I was thinking it was. And then 2 times this, I might as well just leave it. I'm going to divide both sides by it in a second. So this would be 592, and then we just need to divide both sides by this. So it's 592 gets divided by a 2 and the 23.324. And that equals the ds dt. So finally for this one, a 592 gets divided by parentheses 2 times 23.324. So it's 12.691, and this would be in miles per hour. So this distance is increasing a little more than 12.5 miles every hour. Then for a different type of example, a basketball. So basketballs are round. If it's in 2 dimensions, it's a circle, but basketballs are in 3 dimensions. So that is a sphere. And if you look at that part right there, this inches cubed, that's talking about volume. So if it's a sphere and we're talking about volume, we're going to need the formula for that. Hey Google, what's the formula for the volume of a sphere? Oh, good job, Google. There's the formula for the volume. Then how fast is talking about the derivative. So it's saying find the derivative of the radius. Or in other words, find the derivative with respect to time. And I know that this is supposed to be dt because that down there, seconds, that's time. Now, one thing that you need to watch out for every once in a while, doesn't happen on this one, but you got to make sure that the units are the same. So this one's in inches, that says inches, so it's all good. If this said feet and that's inches, then we need to change it so that everything's inches or everything's feet. Here, they already match. So this is the formula, then take the derivative. So dv dt, and then when you take the derivative, the 4/3 and the pi could just sit there. For r cubed, the derivative is going to be 3 times r squared, and then do the chain rule, take the derivative of the r. And then that's good news because that's what we're supposed to solve for. And we could just plug in that r is a 4.7. The only other thing we need to know is this. And that's what this 30 is about, because that's volume over time. So that right there is the dv dt. And then just substitute 4.7, the size of a regulation basketball, has a radius of 4.7 inches. That right there, I did literally Google that to find out the radius of a basketball. All right. Oh, look, these 3's can cancel. Time for a red pen. And then to solve for dr dt, all we need to do is divide by 4 pi and also this. So it's going to be that 30 gets divided by a 4, a pi, and also a 4.7 squared. And then calculate. So 30 gets divided by parentheses 4 and pi, and also 4.7 gets squared. So it's a 0.108. And what would the units be? Well, radius is given in inches and this is in seconds. So the radius would be growing at just a 0.108 inch every second. And now for a different type of example, number 4. Right circular cylinder is being filled with water. The rate, so that's volume. Inches cubed is volume, so it's basically telling you the dv dt is 210. How fast is the water level rising? If the radius is 2 feet. So here's an example where I'm talking about that this is feet and that is inches, so we need everything to be in feet or everything to be in inches. Well, changing cubic inches to cubic feet is not the easiest. Not bad, but changing feet to inches, that would be easy. So there's 12 inches in a foot, so this means 24 inches. So just change that one over to 24 inches. Now, what's a right circular cylinder? Well, if you've ever had a can of soda, you were holding a right circular cylinder. So circular, yep, means it's a circle. And cylinder basically means you take the same shape and you stack it up again and again and again. So imagine if you had a quarter and you put another quarter on top of it, another quarter on top of it, another quarter on top of it, another quarter on top of it. You're creating a cylinder. In fact, you're creating a right circular cylinder. Let's see how my 3D drawing skills are today. Does it look like a soda can? Thanks. Okay, so this is actually much bigger than a soda can. This is like some kind of cistern or water storage device. Now on these pictures, as I mentioned before, if something's going to change, you have to use a variable. If it's going to stay the same, you could use the number. Well, as you fill this thing up with water, it's not going to change the radius. So that means that right here for the radius, we can just go ahead and use that it's 24 inches. Now what is going to change is the water level. So let's say that this is the water. So all of this is the water. Now we need to know the formula for the volume, because as I mentioned right there, that's volume. So we need the formula for volume. So the formula for volume goes like this: pi r squared. Right now your brain should be saying pi r squared, that's the area of a circle. So if you do pi r squared, that will find the area of this circle that's on the bottom. And then stack them up, stack it up, stack it up, stack up like you're stacking quarters until you get to right here. So this will be the height of the water. This, I cannot put a number because it's going to be changing, so I need to use a variable like h. So anyway, you multiply by h, that's the formula for the volume of a right circular cylinder. Now, because the r is a number, we can go ahead and substitute that in. There we go. And now take the derivative. So on the left side, it's going to say the derivative of the volume with respect to time. Again, I know that this is supposed to be dt because down there at the bottom it says seconds, so that's time. And then the pi and the 24 can stay there. And now take the derivative of h. So the derivative of h with respect to t, which means how fast is the height changing over time, which is what I was asking right here. How fast, so that means derivative. The water level rising, so how fast is h changing? So we just need to do two more steps. One is, this is the dv dt, so substitute that in. And then the last step will be just divide by this pi and 24 squared. And then we'll be done with number 4. So it's going to be 210 gets divided by a pi and also a 24 squared. So a 210 gets divided by a pi and also a 24 gets squared. And that is a 0.116. So 0.116. And I change this over to inches. So this is going to be inches per second. One other little detail on this one is because the shape is the same as it goes up, that means that this is going to be a constant. So at the very beginning, it's going to be going up by this rate. By the time you get up to here, it's going to be going at the same rate. Now, if it was some other type of shape, like some type of triangle shape, then at the beginning, because you have very little space here, it's going to fill up fast. And then when you get to the top up here, it's going to take, if you only put a little bit of water in there, it's going to only raise it up a very small amount. But when the shape is the same, then this is going to be a constant rate the whole time. And one last one, number 5. Suppose that you take a pole or some other straight object and you lean it against a wall. And then for some reason, somebody greased the wall and the pole starts sliding down the wall. So we have a wall right here, and this could be the ground. And then the pole is leaning against the wall like this. The top of the pole is going to be sliding down, which means that this part is going to be sliding out. And like I said before, if there's something that is not going to change, you can go ahead and use a number. If it's something that is going to change, you have to use a variable. Well, this 10-foot pole, as it slides down, it's not going to change. It's still going to be a 10-foot pole. But this distance from the base of the building out to the end of the pole, that's going to change, so call it X. And then from here, the top, down to the ground, that's going to be Y. And assuming that this building is standing upright, we have a right triangle. So you could use the Pythagorean theorem, x squared plus y squared equals 10 squared. Okay, I just noticed something. Feet, inch. So the majority of them are already feet, so I'm going to leave it in feet. I need to change this. So 3 inches per second. So 3 inches, that would be 3 inches out of 12 inches. So that would be 1/4. So this is going to be 1/4, and now it's saying feet per second. And then just reading the rest of it, there's seconds right there, and then nothing else says about time. So we can go ahead and use feet per second. Okay, then take the derivative. So it's going to be 2x and then times the derivative of x with respect to t. And then 2y times dy dt and equals 0. Now on all the other ones, I plugged in the numbers and then did the algebra. I could also do it the other way around. I could do the algebra right now. So how fast is the bottom sliding out? So the bottom is x. So we need to solve for dx dt. How fast is the x changing? So this, move it to the other side. It'll become negative 2y times dy dt. And then divide both sides by 2x. And when you divide, the 2's are actually going to cancel. So dx dt, the negative will still be there. The y times dy dt will still be there. And then divide by x. All right, let's see. How fast is the bottom sliding out when it's 7 feet? So when x equals 7. So again, this is going to be the calculus part. Right here, I need to do some algebra. So when x equals 7 feet. So then use the Pythagorean theorem. 7 squared plus y squared equals 100. This is 49. So subtract 49 from both sides. 100 minus 49 is going to be a 51. And then take the square root, so it'll be the square root of 51. And then substitute that information over here. So it's going to be negative, replace the y with the square root of 51. The dy dt, so the pole slides down the wall, so that is y information, because the y is going down the wall at 3 inches per second. So because it's going down, that means the derivative is negative. So I actually need to substitute that it's negative 3 for the dy dt. And x is a 7. All right. Just use a calculator and we're going to be done. So these two negatives are going to cancel, and then it's going to be the square root of 51 times a 3 and divided by a 7. So it's 3.061, and the units would be feet per second, and that is how much this x is increasing. So notice that this is a positive because as it slides down, the x is going to get bigger and then bigger and then bigger. So if the x is getting bigger, its derivative is positive. The y, on the other hand, would get smaller and smaller and smaller. That's why we had to use negative on this 3, because the derivative of the y would be negative. All right, so that's it for related rates.